So I recently implemented shadows in Hackmatrix. You can see this guy has a shadow here now. And I want to show you how I implemented it. So here I am in my fragment shader. And this is the light function, which computes how the color is expressed in each fragment. It has ambient, diffuse, and specular light, but I want to take a look at the shadow right now. So the primary function for that is the shadow calculation. So this is the function that computes shadows. And the most important parameter that gets passed in is the depth map. The depth map is rendered relative to the light. What it does is it renders the scene from the perspective of the light, and for every position in the scene, it computes the closest fragment to the light. And so what this means is in this particular vector, the closest fragment would be a fragment on the person relative to the light. And so using this depth map, which contains the closest fragments relative to the light, we can grab the closest depth. So what this function does is it computes the distance or the vector from the light position to the fragment position. And this is any fragment in the scene. And so let's say that we want to do that for a fragment in the shadow here. This vector from the light to this fragment in the shadow will be quite large relative to the light to a fragment on the person. So for that particular fragment in shadow, this frag to light will have a length that is greater than the closest depth. And so if the depth, the current depth, which is the length from the light to the shadow, is greater than the closest depth, which is the depth that we pulled from this depth map here, then the shadow component is 1, which means that it is in shadow. Otherwise, it is 0. And so when this function runs on the GPU for a fragment, let's say the corner of this guy's chin, it will say that, nope, this particular fragment is actually the same depth as the fragment computed, or the depth computed in the depth map, and therefore it is not in shadow. However, this fragment, let's say on the corner of this cube here, its length to the light source is longer than the length to whatever fragment is causing the shadow to appear, and so it will be in shadow. And therefore its value will be 1. And so when all is said and done, this shadow component contains a 1 or a 0, and then it gets added to the ambient, diffuse, and specular light with 1 minus shadow. So if it's in shadow, this component is 0, which means that light is not added. If it's not in shadow, then this 1 is added, giving it a little bit of extra light. And so you can see all the objects. With this crystal, it has a shadow. This man has a shadow. Even the apps that you see running here has a shadow. These shadows are dynamically computed. So if I were to walk through this door here, you can see that there is some light. This strip of light is streaming in from the light source. But if I were to close the door, that strip of light would disappear. Originally, I didn't even want to add shadows to my game, but in order to have one light in one room and another light in another room, and not have the light in another room bleed through and create light where it shouldn't be, I actually had to create shadows so the light would stay inside of the room it's in.